Hello class, welcome to part 2 of the stoichiometric videos. Let me clear this up for us, moving on to something new. So this is part 2. Right now last time we talked about the definition of a mole, what it is. This time we're referring to the molar mass. So the molar mass is the mass of a mole. Surprise, surprise. So we get this from the atomic weight of the element on the periodic table. So for carbon, has an atomic weight of 12. Therefore, 12 AMU, we can convert that to 12 grams per mole. So let's look at that unit real quick, grams per mole. This is the mass of a mole. So that's how we're going to refer to mass at this point. So it's the same number, we just change the units from grams to moles, or from AMU to grams per mole. How can this help us? Well, if you want to convert between 150 grams of carbon, and carbon has a mass of 12 grams carbon every 1 mole of carbon. That gives us a ratio, and we just use our calculator to find out the quotient. .5 moles. So we can find the number of moles from an amount, or we can find the grams from the number of moles. For example, if we have 2 moles of CO2, well, let's figure out 1 mole of CO2 is going to turn out to be 12 for carbon, 16 for oxygen, and there's 2 of those. So 16 plus 16 plus 12 is 44 grams. So just to rephrase, carbon is 12 grams per mole plus 16 times 2, which is for oxygen. That gives us 44 grams for every 1 mole, therefore 88 grams of CO2 into moles. So we can convert between the two, and that's really, really useful. Excellent. Last thing we can use is, combined with Avogadro's number, we can say, oh, I don't know, if we're given, let me write this down better. Given 2 moles of CO2, find the number of molecules of CO2. Oh my goodness, I totally wrote that wrong. I'm sorry. Given, sorry, long day. Given 88 grams of CO2, find the number of molecules. So if we have 88 grams, multiplied by a conversion factor, 44 grams of CO2 in every 1 mole. Now I converted to moles of CO2. And then I know that for every 1 mole, I will have 6.02 times 10 to the 23rd molecules. Therefore, now I have 2 conversion factors. I'm converting from mass to moles here, given my molar mass, and then from moles to molecules here with Avogadro's number. So I'm going to put a little a algorithm number, and then I'm going to put molar mass. So these are my two conversion factors I'm adding together. And as you know from dimensional analysis, to answer this, we will just multiply across the top, divide going down. We would end up with, let's put this down here, 1.2 times 10 to the 24th molecules of CO2. So those are some examples of how we use molar mass and how we use multiple different conversion factors to get to what we need. Cool. So let's go through a couple more ideas. Here's what I just wrote down in probably neither. The location of using molar mass and Avogadro's number to calculate from grams to units. We have different mole relationships. This can be slightly confusing. So in something like CO2, which same as saying C1O2, and we have an imaginary one here, this tells us a few things. A, 1 mole of CO2. We also have 2 moles of carbon. Oh my goodness, 2 moles of oxygen and 1 mole of carbon. So we can use this number for moles of that. We can use this number for moles of that. And of course we can use this number here for moles of the whole thing with the imaginary parentheses. So with that ratio, we can also say things like nitrogen, N2, well there's 1 mole of nitrogen gas, but 2 moles of the element nitrogen. And that little G stands for gas. So we can use 2 different types of numbers. They both refer to the same thing. That's very commonly confused because we're using the same amount, mole, for different things. But when it comes down to it, just remember there's one piece here, there's one piece there, and when we use moles, really just talking about an amount of stuff. Alright, I think that's all I want to talk about for this one. Let me just write down one more thing here. Coefficient, E, coefficient is the number of moles for the molecule, and the subscript, number of moles for the element. That's just some other hints to write down in your notes. Excellent. So there's another video, part 2, and we will talk more in class. Otherwise, have a good day.